forward. So we've got the second session today in this room, and that's going to be on From Immersive Touch to Embodied AI, How Haptics Bridges XR and Robotics by Vasilapostolos OURANIS from Haptikos, Inc. I hope I'm pronouncing your name correct. Please join me in giving a round of applause for our next speaker. Over to you.
Hello, good morning, everybody. Thank you so much for the invitation and the opportunity to present you today something that is going a bit beyond the usual area of extended reality. Actually, my presentation focuses on how we can exploit XR technologies in a way to add value to all other fields, something that we are experimenting at Haptikos. So I'm Vasilapostolos OURANIS, co-founder and chief technology officer at Haptikos. And I would like to start with a public video from NVIDIA to see how NVIDIA is exploiting extended reality, like virtual reality environments, motion tracking, head-mounted displays, in order to collect data, actually to provide the capability to an operator to act like a robot in the virtual world, in order to collect data and then train the robot to perform general purpose tasks in the physical environment. And this is because with the rise of AI and really sophisticated hardware, companies like Boston Dynamics, Tesla, Figure, really sophisticated hardware, they found a meaningful application because of the AI. So we can say today that it's the ChatGPT moment for the robotics. But in order to reach this level, we have to overcome certain challenges. So the first challenge is the multimodality. What that really means. I said that we have really sophisticated robots, and this hardware, in their core part, they need several sensors to perceive the environment or to act inside it. So we need, let's say, optical sensors like cameras in order to have a visual analysis of the environment, so the robots are capable to understand where they are and how to operate. Then we need actuators to move the robots, and inertial measurement units to rotate them, and so on. And this is a really, let's say, tough from the mechanical and industrial point of view exercise to find the right balance between sensors and what the purpose of this specific robot to perform. Then we have the data gap. So let's say we have the sensors, we know what we want to achieve, but in order to make these robots work, we have to train them with certain types of data. And most probably, most of you experimented ChatGPT in the early days, where the outcome, when you were prompting, is not that, good as it now, and that was because of the lack of the data. So the same happens in the robots part. So we need to generate data that are expensive to produce, and they need time in order to train them to perform difficult and high-fidelity tasks. And at the same time, these data are going to be evaluated in the physical world. So we know, as I said before, companies like NVIDIA, they do have simulator environments like the Isaac Sim, where they get the data and train inside the simulation to perform a certain task. But when it comes this outcome to be experimented in the physical world, we are not guaranteed that we are going to get the same outcome. So the evaluation challenge is coming to remind us that when it comes to deal with the physical world, we have to take seriously things like security, collaboration between robots and human beings, and this provides us the capability to go back to the multimodality thing, re-engineering what works and what it doesn't, and then regenerate data because, for example, we couldn't take into consideration when we were designing the previous two things the level of friction or the gravity. So we have to experiment all these things that we deal with in the real world and provide a more sophisticated model at the end of the day. And of course, the robots should be able to respond to these challenges that they are dealing in real time in the physical world in milliseconds in order to be capable to work as they should work. You have to take this slide, this graph, as a ladder of intelligence of robots. And starting from the bottom left, the robots and how we started designing them, we tried to make them able to perceive the environment. This is the first step. In order then to, based on the generative AI, as you know, the robot to be able to imagine what they should do in order to perform a task. Okay. Since we have this imagination on the robot, then we have the agentic AI, where the robot should create a concrete path of steps with a certain order in order to accomplish a specific task. Let's say that I have to grab this thing and put it on the desk. So the robot should understand where this is, where the perception AI helps it. Then we have the generative AI, where it imagines general and different options of how to do that. And then, based on the agentic AI, it selects the best option of doing this task with certain tasks. And then it comes the physical AI, how the robot can adjust based on the physical conditions that it has to encounter with. And this is the most difficult thing at the moment to generalize, because as you can understand, modeling all the physical dimension is something that doesn't exist in the physical world in terms of data, and here is why the data are going to play so crucial role in this further engagement of robotics. So in order to overcome these limitations of the past, we have to create what we say the data mix. So the data mix comprises three main data types. The first one and the foremost is the real data. So the real data, you can imagine that we can have a robot, like an anthropomorphic robotic arm and a gripper, and then we map this robotic system with a human-robot interface, like a VR haptic glove. So what the glove provides 3D localization of the hand, motion tracking of the fingers, and rotation of the palm, and most probably haptic or kinesthetic feedback. So we can map all these data types to the robotic system, and we can remotely teleoperate at the same time capturing data on how the robot should perform a certain task. So while since we have a good system there, a good integration, an accurate outcome between the physical, what my hand is performing, and the robot, then I can use this real data as the template into NVIDIA Isaac Sim, for example, this platform, in order to extrapolate the use case that I'm performing from 100 times that I'm doing that in order to collect data to 1,000 or million. Why this is really important to have also the synthetic data? Because we can randomize, let's say, the case that the robot has to deal with in the real world. It's not going to learn just 100 ways to grab a glass or a thing, an object. So we have to randomize that in order to make it able to deal with every situation out there. And of course, the internet data, like video, that can help him combine with the previous one on how they perceive the environment, to understand where they are and what they have to, what's the deal, the over deal, and in order to design the trajectory that they are going to follow. So for that reason, in our case, we're exploiting our solution. So that's why we have developed Haptikos. Haptikos is an ecosystem of hardware and software components, and its core, it's the design of a very robust system that can measure the motions of the hand in a very accurate way. And you will see later on all the capabilities of this technology. So in a nutshell here, you can imagine that a robot should sense like a human. What that means that when we are doing the teleoperation thing mentioning before, the robot, when I grab something, should feel that the softness or the hardness of the object, the size, okay? And that's why we have, in the hardware side, tracking sensors to measure the motion of every joint of the hand, haptic feedback to understand the surface, if it's smooth or hard, and kinesthetic, about the size and shape of the object that they are interacting with. And we said before about the AI, but in order to make this happen, everybody should have some motivations, and we think that this is the right time to do that because of the technology that we have developed. Of course, a market that, as we said, players like NVIDIA, Tesla, they're investing on that, and a team that is capable of make this mission happen. Starting from the product, here you will see the three main components of our system. The first one, on the top left, is how the exoskeleton can track 24 degrees of freedom, more or less all the joints of the human hand in millimeter level of accuracy. And this is really important when it comes, you will see later on, in the teleoperation aspect. You have the robot to act like you do when you are performing a task. Then we have the tactile feedback. So when you teleoperate the system, you have the sensation that the robot is feeling in order to have a feedback on your side that, okay, the robot, this is fragile, so I don't have to apply more pressure than the expected, so most probably the glass is gonna break. And of course, since we are speaking about general purpose robots down the road, we have to create a system that is easily to be used from everybody. We see robots that they are going to help us not only in the industry, but also at home. So everybody should be able to generate data that are going to be the main food for them in order to be capable of performing tasks also in our home. Speaking about the software, of course, as I said before, we have a really sophisticated hardware, but how we are going to exploit that in real applications. So the Haptikos app is the main native app where we are collecting the data, and then since our system is mechanical-based tracking, everybody of you can create their own profile with just their own calibration. So we have just one pose calibration. You have just to keep your fingers open and stretched, and then you can save this profile, and every time that you are going to reuse your system, no need to recalibrate. This is really important from the adoption point of view and how everybody is going to use that in a daily basis. And of course, the motion recording and playback here is, we provide the capability of recording data that can be used either in extended reality applications or robotics. And of course, an API that can provide this data in custom platforms or ready-to-be-used platforms like Omniverse or NVIDIA Isaac Sim. Here you can see how we have integrated our system with most probably the most sophisticated robotic gripper there, the Shadow Dexterous Hand. So it's really important for us and for every software provider to provide a technology that can be adopted in every industry need, because everybody is using different technologies. So from our perspective, it's really important to provide an API that can be consumed from everyone. And here, this is a real example from one of our partners in the US, Tetra Dynamics, where they, as you can see, they do have their own robotic system. And they are using our exoskeletons in order to train the robot to perform and solve a kid's game. So here, on this video, you will see how they collect data with the remote teleoperation mentioned before, and the dexterity that our system provides to the operator to perform tasks with a millimeter level of accuracy. Okay, so you will see here how it manages not just to grab the cube, but also to rotate it in order to bring it to the right position. And guess what? This is 100% autonomous. So the robot is capable of doing this task and repeating that without even failing on it. And here, I think later on this video, you will see an unexpected event, also mentioning in the early of my presentation, where the robot is going to treat an unexpected event. It goes very well. So far, so good. Oh, so here the robot should understand that the object is not in its fingers, so should try again and deal with the real situation that we deal in the real world. That's from my side. I think we have some time for questions. Thank you so much for your attention. Any questions?
My question is a quick one. It's when you mentioned the recalibration that's done once, is it based like on user profile, or is it more like you record some sort of metadata so that you don't even record the need to have like create a profile, blah, 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 and then do all of that? Yeah.
So thanks for the question. As I said, our mechanical system is, the tracking system is based on mechanical technology. So the system provides us the capability to read and measure the hand size. So in the anatomy, there is analogy on how the hand is bigger or smaller. So we have taken this analogy into consideration, and we recalibrate the system based on the hand size that we read compared to the reference one that we have created, our basic model. So you have to do just one pose, so then the calculation is that we're measuring the hand, and we apply the model, adjust the model, the tracking model based on the hand size that we are measuring. And we can save that because it's mechanical, so it's not digital, that we need to recalibrate every time that we are using it. Any other questions? or we are ready for coffee, most probably. It's too early.
Perhaps I can ask some questions. So where have you already seen deployments of this? Which use cases have you already deployed it and you're kind of seeing early traction? If you can share some light on that.
Since we are a small team, and I think everybody here can understand how difficult it is to develop technology and at the same time trying to get adopted from players out there. So we try to find champions, let's say, customers or partners. What that means, people that they really care about technology because it provides them value. At the moment, we speak with high-profile organizations and try to find a certain way of collaborating in order not to distract us from what's our mission, but at the same time to support them and at the end of the day, co-create the technology that they need. So we've worked with Siemens or Leonardo from Italy, so with big players out there. But the idea, every time that we decide who's going to be our next customer, it should be aligned with our, let's say, specific mission of reaching the outcome that we need to achieve. So if there isn't any other question, thank you so much once again for your time. And enjoy. We have a booth in the expo in case you want to experiment the technology firsthand. And thank you so much again.